Okay, we've done the lineup. In other words, we've showed you all the pieces, parts, all the components, and now we're going to start the video clips of the actual construction. Welcome back, by the way. If you just stumbled across this video, you look down there and see it says V1.3 Volume 1. That's actually Part 4, trying to honor the fact that everything in a computer starts with 0. So you've got Volume 1.0, 1, 2, 3, 4, maybe we'll have 5 or 6, I don't know. But anyway, if you're just starting here, you're starting in the wrong place. So back up to V1.0 and watch the videos. Okay, because the push button and the toggle switch are right next to each other, we could take one conductor and bring it in through the push button to an outside pin on the toggle switch. Now, this is not an easy task if you haven't done a lot of things like this. Now, I'm going to, in a second here, show you how to do it right on the back. But what you could do is just strip this back a little bit further and pull these further apart. And then when you put them in the hole, bend this wire upward so that both switches drop right in the holes on the panel. Okay, let's give this a whirl. So you can see that I have the wire run through that pin on the push button and that pin on the toggle switch. And the trick is to not apply too much heat. So I'm going to come in and try to use the, see, no more than a couple seconds on each pin. So this one's a little bit more sturdy, so I don't have to be quite as careful with this one. Now I'm going to pick this up and show you a little bit closer what the solder joint looks like. It's very difficult because this camera is not a professional camera. So I don't know if you can see that the solder has to flow evenly. See, I'm going out of focus here. It should wet both of those pins and the conductor. I don't know if I can get this in better focus or not. Yeah, so you'd have to do this 10 times. Or you can solder them up outside of the panel plate and then install them. Okay, here's a close-up of one of the combination solder joints, and when I soldered the wire was actually horizontal, and then once the solder cooled, then I used needle nose pliers to bend the stiffened wire. It's stiffened by the solder, to bend it coming away at 90 degrees, and you can see that I did that on all of the connections. That's to keep that particular connector away from the one right adjacent to it. So here I have all 10 of them done, and it didn't really take that long. Okay, I only had 6 colors: brown, orange, yellow, blue, green, and white. So you notice that starting from the right, you see brown, orange, yellow, green, blue, white. Then I started over again with the exact same combination, the exact same order: brown, orange, yellow, blue. Okay, I didn't have a green and white because I only have 10 there. But notice that what I did was that I kept the groups in separate clusters. That way when I'm connecting up the other end, I won't have quite the challenge to tell which brown is which, whether it's the brown from the first or from the 7th group. So it's a good idea to keep the same pattern of color if you're going to reuse the same color. In other words, keep the pattern the same, and it gives you a little bit better organization. Okay, now what I'm going to do is I'm going to tin the other pins. So I'm going to apply a little solder. To each one of these. If it doesn't stick, don't stay there until it does. Come back to it, because you don't want to apply too much heat. Just enough so you got solder on every one of them. I see a joint here I don't like, so I'm going to add a little more solder to it. Okay, that's what's going to be the common for the push buttons. Now we'll turn it over and we'll do the commons for the toggle switches. And that's going to be the center pin. Again, it's better to come back. So I didn't get that one or that one. Don't just keep applying heat, because you can very easily melt the switch body. Then you have to pull out that switch and start all over. So you just touch a little solder, go back, see that needs a little more there. So you don't apply too much heat. So now we have the center pins on all the toggle switches tinned, and we have the commons on all of the push buttons tinned. Next thing we want to do is to add the common conductor. So I have this great big long stripped piece of wire. See this red wire right here? And then I have about 16 inches or so of it stripped off, and it twisted tightly together. Then I tinned it with solder. So there's solder already on this twisted wire. So I'm going to go to the first joint here and solder that one good. Let it cool. So now I've got my wire anchored. See, so it's not going to give me a hard time. And you can see that this is a great big long wire. So I'm going to go down and solder this to each one of these common pins. Then I'm going to come around and do the same thing on the other side. Okay, after you have this all soldered up, you want to check your work with a meter. So you see I have the red common, that bare wire that went all the way around, that's common to all 20 switches. I have it connected to the black lead of my meter. It doesn't really matter what lead you use, because this is continuity you're checking, not actual voltage. So see, if I touch the common, you see I've got continuity, which you would expect. So if I pick a switch, say this brown one right here, and I find the other end of that brown wire, my goodness, what a mess. You can see I wasn't really prepared for this. If I put my meter on it here, on that brown wire, and reach underneath here, see the meter? And I'm going to do the push button. Now if you turn the toggle switch on, then push the push button, nothing's going to happen, because remember, these are wired in parallel. So there's the push button, there's the toggle switch. You need to do that for all 10 to make sure that it's all properly connected and you didn't ruin any of the switches with too much heat. So although I did it using one red conductor that was stripped back, now that I think about it, that might not be such a good idea. It might have been better to just use one for the 10, bring it out here, use a separate one for the 10 here, and then solder them together on this end, and then trim off the excess, maybe put a little black tape on it or something. Also, you don't have to put your switches this close together. In other words, my nickname is T cubed, Too Tight Timmy, TTT, Too Tight Timmy. That's because I do everything really tight. If you call for a 2x4 6 feet 3.5 inches, that's exactly what you're going to get from me. If you want me to split the cut, you better yell that out when you call for the board. So I tend to do everything pretty tight, and remember that one of my goals for this whole thing was for you to be able to carry this in your little bag and go sit in Panera Bread and drink coffee and eat pastry and do your PLC professor training stuff. So now this box may be a little bit big for that in the end. Plus, if you're going to hook this to a larger PLC, so setting this all up in Panera Bread isn't quite the idea that the little 10-point Micrologix 1000 was. You can just sneak that out of your bag and set up there with your cable and have at it, and hopefully nobody thinks you're building a bomb. Even carrying stuff like this in your carry-on or your computer bag going through the airport, when they see switches and black boxes and stuff, they start getting all excited. Okay, we're gonna wrestle one of these in here. So there's the little bezel. You slide the LED in like such. Okay. Then we're going to take the panel and we're going to thread the wires down through there. I don't know if I can do this and wrestle around the camera or not. But basically, you have to, there's little plastic legs. You can't see that. You have to squeeze them together and force it down through the hole. So you're on your own for these LEDs. The paperwork called for these would go down through a 1/4 inch hole. I had to drill it out to one size larger, which is 17/64. I went to 9/32 and it was a bit sloppy. So you're actually probably better off going with 9/32 and have it be sloppy. Okay, you can see that I have all the LEDs mounted now. So even though I didn't drill the holes perfectly straight, it still comes out and has a pretty even look to it. Now on the back, I've separated the red and the black wires from the LEDs, and I've tie wrapped them to the wires coming from the toggle switches just to get them out of the way. So the next thing that we want to do is we want to put in the potentiometers that go one under each one of the meters. And I know this isn't very focused. This camera is a little older. Just a quick interruption. The next two video clips are small in resolution because I accidentally bumped one of the setup buttons on the camera, and the work had already been done. I couldn't go back and really redo it at the time. But rather than leave them out, I'm including them. And specifically, I think they're involved in installing the potentiometers into the face of the box, which I turned around and took them right back out anyway to give me more space to do the assembly, and then later we put the potentiometers back in. The key thing to know about those potentiometers, if you're going to use the 10-turn pots and the vernier dial, is when you lock down the potentiometer with the locking nuts, there's a black plastic washer with a notch at one spot. That needs to be at about 8 o'clock. So when you put the dial on, it's set with the open window at the top of the vernier dial. And then there's also a clip where the color got a little flaky. That's because I hit remove red accidentally. So I apologize for that. If you want, you can just take the slide bar and slip through those real quick if you don't want to watch them. Okay, we have the potentiometers mounted, and notice the little positioning plates behind the nut. The notch is at about 8 o'clock. That is a good position for when you put the dial on. We want the little window to be at the top of the knob. Now we have the vernier dial knobs mounted on the potentiometers, and you used an Allen wrench, and there's an Allen screw in the side of the knob that you tighten down on the shaft of the potentiometer. And of course, you can't see it, but you want to line up the vernier dial. You want to turn the pot all the way counterclockwise till it stops. Then set this at 0, 0, and then lock it down. Okay, we've mounted basically all of the hardware. You see the 2 meters popping through from the front, the 2 potentiometers, and then of course the toggle switches, the push buttons, and the LEDs. So now it's time to complete the wiring. And the name of the game in a project like this is wire management. What in the world are we going to do with all of these conductors? Plus we still have to supply power, the dropping resistors, and external wiring for the analog inputs and analog outputs. So let's go to the next step. Okay, I figured out what was wrong. Notice that I've got shrink tubing slid down onto each of the red leads on the LEDs. The black leads, I've got them tie wrapped. I've got the first 5, and they're underneath of this tie down. Then they're twisted together, soldered to a single black wire with shrink tubing on it. So I've got the first red wire ready to go. See, I've twisted it together. Well, it came undone. So I'm going to twist it together, solder it, and then bend it over and put shrink tubing on it. Okay, so there's the red LED and a brown wire. The red LED goes to the first, well, the red lead goes to the first LED, and then it's soldered to a brown wire. Now I'm going to take the shrink tubing, I'm going to slide it up, but first I'm going to fold this over. I'm going to have to set the camera down to do that. Now I doubt it's easy to tell, but I took the twisted ends and folded them back over against the brown wire, and then slid the yellow shrink tubing from the red over to cover up the joint. And remember, the tip of the soldered together wire pairs is facing in the direction of the brown wire. That way it's not fighting getting the shrink tubing over. So we're going to do this for all 10 of the LEDs. Okay, you can see that I have the orange wire and the red wire twisted together, soldered, and then the soldered tip is bent back against the orange wire out away from the shrink tubing. That way the shrink tubing will slide right over that joint and you won't have to fight the soldered tip getting it on the shrink tubing. Now you see I have the first red 6 LED wires soldered and then shrink tubing, and I used the exact same order of colors: brown, orange, yellow, blue, green, white, that I used on the switches. That way when I'm trying to figure out what wires go to what when I'm outside the box, at least I have a fighting chance. Okay, you can see we have the red and black wires from the first 6 LEDs. We've done our wire management to the tie-down pads, and you can see that the shrink tubing falls in various places because this red wire is going to be the shortest when it gets here, shorter than this one. You could have cut them to varying lengths so all the shrink wrap fell in one place. That's probably not a good idea because then it becomes too bulky. So now what we're going to do, I think, is we're going to run our conductors, all of them, out this end of the box. So we want the cables to come out this end. So these last 4 LEDs, we could come around here, or we can come all the way around and leave more of this space in here wide open for hooking up the potentiometers. I think we're going to do that. Thank you for watching Building an Advanced Trainer with Analog Volume 1.3. We'll continue on with Volume 1.4 right where we left off. We're trying to keep these between 20 and 30 minutes. And if you look, you'll find the next section of this on my YouTube channel, or if you order disc specifically with these videos on it, it's next on the disc.